gradient and divergence, now it will be curl. So this is also defined on a vector. This is nothing but cross product with the del operator, not with any other vector. It is the cross product with the del vector. Okay, and del is also a vector, I think you know it, right? So otherwise then there is no meaning in discussing gradient and all. Okay, so the curl of a vector a bar is given like this. It is nothing but limit s tends to 0, line integral, that is circular line integral a bar dot di bar divided by delta s dot product with an bar. Okay, so this is nothing but axial or rotational vector, and the magnitude of curl of a bar is nothing but maximum circulation of a bar per unit area as the area tends to 0, as I mentioned, that is limit s tends to 0, right? So and the direction is the normal direction of the area when the area is oriented to make the circulation maximum. So all these are not so important, like you just need to solve the problems only, don't worry about all this. But you can't say about exams, right? That's why I have written it very clearly. Okay, how we can write that curl definition? You can write in case of cylindrical like this, because I didn't write anything about Cartesian, because that is easy only, because that is just ax ay az dou by dou x dou by dou y dou by dou z and capital Ax capital Ay capital Az. That's it, that is easy only, that's why I didn't write. But for cylindrical, how it is going to look like, that is important for cylindrical and spherical. So this is a formula like this, because here that del operator is same, that is cross product with the a bar. So that a bar is nothing but your cylindrical coordinate systems vector. So you all know in the first lecture I mentioned it as aero capital, means coefficients are aero rho a by az, right? That you need to substitute here. Okay, but you need to divide that whole with the rho. Okay, you just observe that. Then curl of a bar in spherical coordinate system, so it is going to be look like this. It should be divided by with r square sine theta. So you just go through that, and these are the properties similar to the properties that I have shown for gradient and what divergence. I have shown for this curl also, so you can easily go through them. And the important formula I have written in rectangular boxes, that is divergence of curl of a bar is 0, important, it is very important. Okay, and similarly curl of gradient of v is 0. Okay, so you just observe those terms, means divergence of curl of a vector is 0, similarly curl of gradient of a scalar is also 0, right? Thank you. The divergence theorem, where it is relating divergence with the differential surface, right? Here we are going to relate the surface element with the line element. So in case of divergence there is a relation with differential surface and volume, but here we are having with differential line and differential surface, that is very important. Okay, so Stokes theorem is saying that circular integral of a bar di bar is nothing but surface integral of curl of a bar. Okay, thank you.